Hi everyone, let's take a look at number 3 on page 407. For each of the following calculations, say which are possible for vectors in three-dimensional space and which are meaningless. Give a brief explanation for each. Step 1, if you think about the 6 different problems in number 3, there are 3 basic cases. So if you let S equal to a scalar outcome, and if you let V be a vector outcome, there are 9 cases you want to think about. So for example, if we take a scalar and you multiply this by a second scalar, this will always give you a scalar outcome. So for example, 5 times 7, that's going to be some number. Negative 2 times 1, that's going to be some number. Now, likewise, if you think about a scalar multiply by a vector, so for example, 5 times vector w, negative 2 times vector x. This will give you a vector outcome. If you take a vector and you multiply by another vector, this becomes meaningless. So again, you have to be mindful. When you talk about 2 vectors, you can either take the dot product, you can take the cross product, but you cannot just multiply 2 vectors. Now, if you keep going and you think about this in terms of dot product, you can take a scalar, dot it into a scalar, and again, this is going to be meaningless. So for example, you cannot say 5 dotted into 7. That doesn't make sense. You don't get an outcome, so it's going to be meaningless. And if you take a scalar, dot it into a vector, so again, 5 dotted into vector w. This again, it's going to be meaningless. If you take the dot product of 2 vectors, so this you did do, even in the cross product lesson, the dot product of 2 vectors will always give you a scalar outcome. And last but not least, the last 3 you want to think about includes the cross product of 2 scalar outcomes. And again, this could be 5 cross 7, and this is going to be meaningless. You cannot take the cross product of 2 numbers. If you take the cross product of a scalar and a vector, so again, let's say you're thinking 5 cross vector w. This is going to be meaningless. Last but not least, if you take the cross product of 2 vectors, which is the basic concept behind the cross product lesson, this will still give you a vector. Now that you have all 9 cases, you can now try number 3a all the way to 3f. So, if you think about part A, you're taking A dotted into B cross C. So this means, if you look at the brackets, B cross C, vector B cross vector C, that's going to give you a vector. And of course, the dot product of 2 vectors will give you a scalar outcome. So this is meaningful, and the outcome is going to be a number, a scalar outcome. Part B, if you're looking at the dot product of A and B and crossing this with vector C, this will give you, so again, the dot product of 2 vectors will give you a scalar outcome. But if you cross a scalar with a vector, this is going to be meaningless. Part C. If you take the cross product of A and B, and you also take the cross product, or not the cross product, but the sum of C and D, and dotting it, this equals to, again, when you find the cross product of 2 vectors, that's going to give you a vector outcome. And when you add 2 vectors, that's still going to give you a vector outcome. And the dot product of 2 vectors is a scalar outcome. So again, it's going to be meaningful, and the outcome is going to be a number. Part D, if you take the dot product of 2 vectors and you multiply this by the cross product of 2 vectors, this would give you, again, notice there's nothing in between, so this really means multiplying. just to be clear, if there's no symbol in between the two brackets, it means you're multiplying. If you take the dot product of two vectors, that's a scalar outcome. If you cross two vectors, that's a vector outcome. And a scalar multiplied by a vector will still give you a vector outcome. So it's going to be meaningful, and it's going to be a vector outcome. Part E, if you take the cross product of A and B and the cross product of C and D, and you cross the resultant or the outcome, this equals to, again, if you cross two vectors, this will give you a vector. If you cross two vectors, this will give you a vector. And the cross product of two vectors is still going to be a vector. Last but not least, if you look at part F, you're taking A cross B plus C. So if you go through this from left to right, the first step is the cross product of two vectors will give you a vector, and a vector plus another vector will give you a vector outcome. So again, it's going to be meaningful, and it's going to be a vector. I hope this makes sense.